crazy, okay? So yesterday, if you weren't here, you can at least get to the page 139. And within graphing, I review what we did yesterday. So yesterday was pretty easy. It was something kind of new, all right? So as for the notes, I'm going to show you exactly what you're going to do to graph these. So number 7 looked like this. And let's go through, even though you did it in your homework yesterday, let's go through and identify all of the key characteristics. Let's list them. We're going to identify the vertical asymptote, the horizontal asymptote, the domain, and the range. Every single time we need those 4 pieces of information. And that's all we did yesterday was identify that stuff. Today we're going to go a step further and graph it, okay? So let's remind ourselves where these things come from. Okay, my vertical asymptote is always going to be a vertical line, which is x equals something. Okay, remember vax like vaccine, all right? And it comes from the denominator. Look at, there's an x down there. That tells you that's where you're going to get it. When you set this equal to 0 and solve it, we're going to have an asymptote at x equals 1. Okay, the 0 of this, not -1. But 0. And we'll talk about more in a second with the graph of what an actual horizontal asymptote is. I mean, both asymptotes. The HA is the number that's out here to the right. Sometimes there's like a plus or a minus number here. That would be your horizontal asymptote. And in this case, there isn't one. So it's just y equals 0. Okay, but there is one, it's just 0. You're always going to have a VA and an HA in every single one of these. Then remember, your domain is going to be all real numbers except anything that makes your denominator 0. What number can x not be? 1. If you put a 1 there, you get a 0. 1 is a bad number. That's why we put an asymptote at that number, because it's saying you can't have points there. And I'll show it to you visually here in a second. Your range is all real numbers except whatever your horizontal asymptote is. In this case, it's 0. So these numbers will always match up. They'll never be different. Your VA and your domain go together, your HA and your range go together. Whether you put an equal sign or not equal sign would make this right or wrong as well. Okay? It's really you understanding what these numbers mean. And I'm going to explain it to you again, but better today with a visual picture of it. All right, so here's what we do. We're going to sketch this graph. So let's sketch ourselves an x and a y axis. And we're going to put our asymptotes on here first, okay? So what we're going to have is a vertical asymptote at x equals 1. I'm going to make it dotted. So at x equals +1, you're going to have a dotted line. I'm going to go ahead and use highlighters to really help you see. Right there we have a vertical asymptote. Okay, we also have a horizontal asymptote at y equals 0. That's just the x-axis. That's a horizontal line at 0. So I'm going to use a highlighter so you can really see it. So what those asymptotes are 2 places, here and here, that you can't put any points. You're only going to have points, like almost look at it as those 2 asymptotes made 4 new corners. 1, 2, 3, 4. Okay. Here, this first one's going to be a little confusing because it's your first time seeing it, but we do the same thing every single time we do these. So you'll see after we do a few, it's going to be hopefully boring for you. You're going to make just a little XY chart. Notice I left a little space in there. And you're going to pick 2 numbers and 2 numbers only. And those 2 numbers are any number to the left and to the right of your vertical asymptote. So I have a vertical asymptote at x equals 1. So maybe 0, that would be to the left of the asymptote. And then what would be to the right of the asymptote? 2. Could I pick any number to the left or right? Yes, you can. I promise you it's easier just to pick the number exactly to the left and exactly to the right. It makes your math very well. And what you're doing here is plugging it in to the function, right? That's my function. So I'm going to plug in a 0. And I'm not showing all the work. It's just nice to have a little bit of work there. 0 minus 1 is -1, and 1 divided by -1 is -1. So what that means, let's go ahead and just plot that point. I'm going to have a point at 0, -1. That's right here. Do you guys see that it's to the left of the pink, which we knew it would be because we picked it, and below the yellow? That's all we need to sketch the branch that goes in that quadrant. Notice my asymptotes are keeping the branch. See, these are like arms. Think about them as like arms reaching out. They reach out towards the asymptotes, but they don't touch them and they don't cross them. They kind of keep those points in that little area. And they go on and on forever in those two directions, but it'll never go above that or to the right of the pink. Okay? Now we're going to see where there's always two branches. There's one to the left and there's one to the right. So that's why we picked a point that's to the right. So we picked x is 2. So I'm going to plug 2 in. That gives me 2 minus 1 is 1. 1 over 1 is 1. So I have a second point at 2, 1. Right? To the right 2, up 1. And you can see now you're going to have a branch that stays within the pink and yellow asymptotes. Arrows on the ends, like arms reaching out, and that's the graph. That's it. Okay? Let's do another one, because I want you guys to see how every time you do these, they're the same thing over and over again. Okay, even though we practiced this yesterday, you probably have it in your notes if you did your homework. Remember, this is all you had to do for 7 through 10 yesterday was list these. Let's go through it again. If I set my denominator equal to 0 and solve it, I get 0. That's where my vertical asymptote is. Okay, so so my vertical asymptote would be 0. We have an asymptote at 0. It equals 0. It's a line at x equals 0. Your horizontal asymptote comes right from this number right here. Whatever it is your horizontal asymptote. Okay, so if that's important to know. Then your domain and your range are all real numbers, right, except for whatever your asymptotes are. So for the domain, x can't be 0. For the range, y can't be 4. The numbers match up. So I'm going to sketch a graph. Y is 4. So I'm just paying attention to the fact that I'm going to draw over here. I have a horizontal asymptote that's up kind of far. So I'm kind of skewing my graph so I have more room up top. Because vertical asymptote is at 0. Vertical at 0 would be right here. That's my vertical asymptote. And then at 1, 2, 3, 4, positive 4, I have a horizontal asymptote. And you can just use dotted lines, but it does help to have colors, but it's fine if you don't have it. Now, you pick 2 x values. That's it, just 2. You have to pick one to the left of the vertical asymptote and one to the right. So since our vertical asymptote's at 0, I would probably just use -1 and 1. Make it easy on yourself. Just pick the number directly to the left and directly to the right. And we're just plugging right in to this problem. Now, when you have a negative in a fraction, guys, you can put the negative on top, on bottom, in the middle, as long as there's just one. I'm going to go ahead and put it in the bottom, just so I get it taken care of with this x. So when I plug a -1 in where there's already a negative, it becomes a positive, right? -1 is a positive 1. 1 over 1 is 1, and 1 plus 4 is 5. Okay, so at -1, positive 5, I have a point, and that means my branch is going to be in that little quadrant, staying above the yellow to the left of the pink. I plug in a 1, I get -1. -1 plus 4 is 3. So I have a point at to the right 1, up 3. And then you can see where the branch would be. I mean, we could make a table of values for lots more points, but they're always going to look like this. They're like little curves. We would get a lot of decimals. This just gives us one nice point, and then we just estimate where the rest of the curve goes. But every single one of these graphs is going to be two curves like this. They're called branches, okay? Let's do one more, and then we'll do some in the homework together so you can start practicing some more of these. So let's just do number 9. Okay, so VA, HA, domain, range. Anybody, what's my vertical asymptote going to be? Besides Sarah. Nobody knows? What's my vertical asymptote going to be? -4. Remember, your vertical asymptote comes from whatever makes your denominator 0. So you're setting that equal to 0 and solving it in your head. But you know, if I put a -4 right there, -4 plus 4 is 0. That's why we have an asymptote there. Guys, maybe I haven't really explained asymptotes to you. Asymptotes are places on your graph that you won't have a point. Why won't you have a point? Because it's bad. It makes the equation bad. Like, we couldn't have any points on x equals 0 because that would mean you'd have a 0 in your denominator. That would never happen. So you're showing it on your graph with an asymptote, okay? Same with the horizontal asymptote. If you solved it, you would have a 0 in your denominator, and it would be bad. But just remember, VAX go together and HAY. VAX, hey. What would my horizontal asymptote be? 0. It's the K value. If you remember, we learned yesterday that the form of these would be X minus H plus K. You get your VA from your H and your HA from your K. Vertical asymptote, horizontal asymptote. If there's no number there for K, we just consider it a 0, okay? Domain and range, we always say all real numbers except for whatever is up in the VA and HA. Because asymptotes are numbers that are not part of the graph. So that means they're not part of the domain or the range either. Sorry, that's a negative word. Okay? And let's do an XY chart. Well, let's sketch the graph real quick. So I'm going to have a vertical asymptote at 1, 2, 3, 4. X is -4, right? I'll highlight it for you. And a horizontal asymptote, horizontal line at 0. So when I make my, when I make my XY chart, I'm going to pick two numbers, one to the left, one to the right of my x-intercept, my vertical asymptote, sorry. So this is at -4, so I pick to the left and to the right. I know it's tempting to say, yeah, but I liked 0. 0 is easier to plug in. You end up with a really big number that's hard to graph. If you always pick the numbers on either side, it's much more manageable of a graph, okay? Sorry? Well, this is -4. Do you agree with me? This is -4. To the left and to the right. So I picked -5 and -3. That doesn't matter. We just, the way we pick these numbers is a number to the left of the vertical and a number to the right, okay? Because we're plugging in x's, we're not plugging in y's. If I was trying to plug in a y value, which I don't know why we would, that's what I would go off the horizontal asymptote, but we're not. So I'm just going to plug right into the function, so that's 5 over -5 plus 4. -5 plus 4 is -1. 5 divided by -1 is -5. And don't be shy about using your calculator on those. You don't have to do that in your head. So I'm going to have a point to the left 5, down 5. So left 5, 1, 2, 3, 4, down 5. So all that's doing is telling me, okay, I have a curvy somewhere in that quadrant. We don't know exactly what those points are. That doesn't really matter. It's a sketch. We're getting it in the right place is really what we're looking at. Okay? 5 over negative 3 plus 4. Negative 3 plus 4 is 1. 5 over 1 is 5. So remember, when we graph, though, we start from 0, 0. We're going to negative 3, 5. So starting at 0, 0, left 3, down 5. Oh, sorry. What was I doing wrong? Left 3, up 5. It's a positive. 1, 2, 3. 1, 2, 3, 4, 5. So you can see that would be in this little corner. Okay? A lot going on here. Let's go to the homework. I'm going to do 3 of them with you right now. Yep. Yeah, I guess so. Okay, so we're on page 141, 31 through 36. Okay, if you need more graph paper, let me know. And I'm going to start 31 with you right now. Okay, so if you missed yesterday, what we're about to do right here is what you missed, where we're going to identify the VA and the HA, the domain, and the range. Okay, so here's the given problem for number 31, and we're going to pull out all of this information. So remember, your vertical asymptote comes from your denominator. If you set 2x minus 4 equal to 0 and solve it, you get 2. That's the number your denominator can't be, right? Which is what your vertical asymptote is. If I plug a 2 in there, I get 0. So we're going to have an asymptote at 2. There's no value out to the right, so our horizontal asymptote is just 0, plus 0 right there. Domain is all real numbers except for 2. Range is all real numbers except for 0. So asymptotes are bad numbers. They're not part of the graph. They're not part of your domain and range. So they always match up. Okay? So let's sketch this. Let's put our asymptotes on there. So we have a vertical asymptote at positive 2, which is right there. And a horizontal asymptote at y equals 0. Now we will pick a point to the left and to the right of the vertical asymptote and put it in our XY chart. So my vertical asymptote is at positive 2, so I'm going to use positive 1, that's to the left of it, and then to the right of it would be 3. I'm just picking the number on either side of that VA, and I'm plugging it right in to the equation. So 2 times 1 is 2, so I have 2 minus 4 in my denominator. You could pick up your calculator and do this. 2 minus 4 is negative 2, and then my 3 over negative 2, I do get a decimal here. I get negative 1.5, if I did that right. I think I did. Yeah. Is it, what? Yeah, negative 1.5. And then 3 over 2 times 3, I'm just going to go ahead and put 3 right there, that's 6 minus 4. Is 2, we get positive 1.5. I don't know why I drew right in the middle of my graph, but I did. Okay, so to the right one, down 1.5. Okay, it's no big deal. Right, sorry, to the right one, down 1.5 would be right here. Right, we always start our graph from 0, 0 when we graph a point. So right one, down 1.5. So I'm going to have a branch there. Oh, good. I didn't write in the place I need to put a point. Then I'm going to go to the right 3, up 1.5. So that puts the other branch here. They're always going to be in opposing corners. You might have noticed that. Like quadrant 1 and 3 and 2 and 4. Okay. Let's do another one. Aren't these fun, guys? How to get what? Say it one more time. So I went to the right 3 and then up 1.5. Got it? Okay. 32, 5 over 3x. Let's get organized. VA, HA, domain, range. So set your denominator equal to 0. Whatever you get is the bad number. If I set 3x equal to 0, I get 0. Right? 0 divided by 3. So we have a vertical asymptote at x equals 0. And we have a horizontal asymptote at y equals 0. There's no number there. The domain is all real numbers except x can't be 0. Range is all numbers except for, sorry, that's a y, can't be 0. Okay, so we're using both axes as our asymptotes. X is 0, y is 0. So in our table of values, let me predict. Okay, I'm going to write in this little corner because I'm not going to have any graph in there. I'm going to pick a number to the left of my vertical asymptote and to the right. So what numbers am I going to use? -1 and 1. Right? To the left and to the right. Plugging right into this. So 3 times -1 is -3. So 5 divided by -3, it's like, let's just call it -1.7. Okay? It's okay. They're curves. Remember, these are not like straight lines that are really perfect. They're curves. So you might get unlucky and get a decimal like this, but just put it in your calculator, okay? So I just did 5 over -3. This would be 5 over +3. 3 times 1 is 3. So that would just be +1.7. I'm just going to plot that point. Left 1, down 1, and whatever 0.7 would be. Important part is that's where my branch would be. Starting at 0, 0, I go to the right 1, up 1.7, like that. Okay. Okay, 33. If you need more graph paper, you are welcome to it. Let me know. Let's get organized. VA, HA, domain, range. Oh, I sure did not leave myself much room here, did I? Let me look at the graph. Okay. I'm going to make my graph nice and miniature here. Okay, guys, if you set 4x plus 1 equal to 0 and solve it, what do you get? And there's no shame in doing the work. -1/4, -0.25. Decimal fraction doesn't matter. So we will have a vertical asymptote at -1/4. What about a horizontal asymptote? We don't have one again. I mean, we have one, but it's not anything other than 0. Okay? So where the heck is -1/4? Guys, don't overthink it. If this is -1, let me zoom in for you here. If this is -1 right here, -1/4 is like, I don't know, just estimate. Like there. Okay? It's somewhere between 0 and -1. So there's my vertical asymptote, horizontal asymptote on the x-axis again. Oh, I forgot to do domain and range. All real numbers, x can't be -1/4. All real numbers, y can't be 0. So if you missed yesterday, that's what we did yesterday, like I said. Now let me make a table of values. We want to be, so this is a little trickier, we want to be to the left and to the right. It's not really tricky, but what would be a good number to the left of negative 1/4? Negative 1, right? And what about to the right of negative 1/4? How about 0? You could use 1. You're not wrong to use 1, okay? But 0 is even easier to plug in. But 1 is fine as well, okay? I'm really squeezing here. Okay, so 4 times negative 1 is negative 4. Negative 4 plus 1 is negative 3. So we get negative 2/3. What does that look like in decimal land? Negative 2 divided by 3. Let's just call it negative 0.7. Yuck, but it's okay. It's just somewhere between 0 and negative 1. Okay, let's graph it real quick. So starting at 0, 0, we go to the left 1, down a tiny little bit. That's all that means. And then when I plug a 0 in, 4 times 0 is 0. 0 plus 1 is 1. And 2 over 1 is... So my marker's pretty thick, my highlighter. It kind of looks like I'm touching it, but remember, the asymptote is really where that dotted line is. It's over to the left. My point is on 0. The asymptote is at negative 1/4. I just squeezed it in there. Okay. So oh gosh, it looks terrible. I have graphed all of them for you. I didn't write the equation, but you can see the equation in the chart if you're not looking at your own paper. Let me see if I can put it up here. 34 through 36. So I did 3 with you. You do the other 3. Key with everything I just did is here. Oh. Yeah. You need this. Anybody need more graphic trouble? Oh, that's